So I forgot I need to fix the answers for 3.
The last video there was no sound.
Really? That sucks. Well, was there no sound for the whole lesson, or just sound at the start and then it cut? The whole lesson? Well, I have the sound on now. Just have to hope for the best. It's like 50-50, you know? Remember, I'm very cheap by, the cheapest parts I could find, right? If you want to buy me a nicer laptop, that's okay.
I will get a star.
What laptop would you get me?
Okay, I'll buy you one. You can get
I don't know, it'd have to be a really good laptop, like, really good. Now, I'll hold you to it because I have this on tape. Yeah?
6D or E.
You want to see 6D or E? Okay, I'll do 6D then. So, in 6D, you have 2 minus 6 plus 18 plus ... So the A is 2, and what's the OR? Minus 3, good. So the sum is A, 1 minus OR power n over 1 minus OR. Well, 1 minus minus 3 is 4. 2 over 4 is a half. Yeah. So I hope, if the answer's not this at the back, I'm sorry, but it should be that. It is that. Yeah, so 6D, that's fine. Okay, I'll do 7D now as well. Oh yeah, 7D. Yeah. 7D. Okay, so in 7D, we have 1 minus 2 plus 4 plus ... all the way to 256. Now, what's the A here? 1. The OR? Minus 2. And the N, we don't know. How do we find the N? Yeah, UN equal to 256. Yeah. Now what is UN? It's A or to the power n minus 1 equals 256. Let's use our trick again. This is minus 2 to the power of n over minus 2 equal 256. I can bring this up here. So I get minus 2 power n equals minus 512, which is minus 2 power n, 2, 4, 8, 16, 32, 64, 128, 256, 2 power 10? Is 512 2 power 10? Or power 9, is it?
Power 9, yeah.
Okay. Minus 2, so minus 2 power 9 is minus 512.
So n.
Yeah, so what's n? 9. So that can go back in up the top here, n is 9, and now I can use my sum formula. The sum equals A times 1 minus R power n over 1 minus R, which is 511. Come on, you all have calculators in front of your faces. Will you type it in and tell me what you get? Is it 511? Good. Okay, so write that down, please. Yeah, that is trickier than the previous one because there's a couple of things you have to do there. So please write that one down. Yes.
You said that you divided the first one minus 2, but the second,
You're talking about this here.
yeah.
Yeah.
Why the other one is
Oh, I scratched this out and brought it up to the right. I cross multiplied. Yeah?
How do you get it? Did you divide it by minus?
I multiplied both sides by -2. And what I did here, I used a little trick I showed you last time, which we'll see in the next chapter. When you have powers which are subtracted, you can actually write it like this, as 1 over the other. Now, if you want to write that out, basically what I said was, where did I write it? Here. A power n over a power m is the same as a n minus m. That when you have a minus in the powers, you can separate them as a fraction. That is just something we'll do in the next chapter, but for this week, you just need to know it as like a fact. But we'll see it in the next chapter in more detail, yes?
Actually, the sum is
I don't know, because I don't have a calculator. Is this 511? I don't know.
513 over 3.
Yeah.
513 over 3.
This here?
Yeah. I wonder why.
So it's not 511.
You see, possible.
Andy, please, don't do this to me. Shh, no. So, no, who told me it was 511?
171. So accurate.
That's 511. So when you say it's 500, I saw 511. That's 5, 6.
No, it's not the answer. But we're doing 7D.
Yeah, I listened to that next time. I saw 511. So 511.
Sorry, the answer was 511 over 3, was it? Or 513 over 3. But you all have calculators.
Why you do multiply -2? Why minus division?
What? I think you're asking the same thing Mohammed is asking.
No. This is the last one.
Which one? Here?
No. Or -2 over -3. You're going -2 to the
Yes.
another side.
Yeah.
And you left -2 to the bottom end.
Yes? Yes. All right. I'm going on to the next chapter now before I lose my mind. Okay. Limits. Let me show you a useful result here. So, suppose I want to calculate this. How would I do this from chapter A? I would use long division. Although it looks a little bit strange because it's quite small. But let's use long division nonetheless and see what we get. So we have 1 minus r divided into 1. So what do I multiply 1 by to make 1? Oh, we are sharp today. So this is 1 minus r. And then I subtract. And what am I left with? R. Positive. Now, what do I multiply 1 by to make r? And then I multiply, and I get r minus r squared. And I subtract, and what am I left with? R squared. One more. What do I multiply by 1 to make r squared? R squared. I multiply, and I get r squared minus r cubed. And what am I left with? R cubed. Etc. So this is going to keep going, right? So we have this result. 1 over 1 minus r equals 1 plus r squared plus r cubed. Infinite, no limit. However, you may notice that there's a problem here when r equals 1.
0.
Yeah. And in fact, it's actually a problem if or is more than 1. The full reason is not important to you right now in your life. So I'll just tell you, or needs to be a number between -1 and 1. And we have this result.
Zero.
Hmm?
It must be zero.
What must be 0?
Yeah, so it becomes
Or?
after.
No, wait,
Yeah.
wait, what? No, hang on. I'm hearing many different things, none of them right. So, what's the question?
Noted.
No question?
That's all.
No question?
So it's infinity right now, yeah?
No. My writing of the infinite symbol here is to show that this continues with no limit. The next would be or 4 or 5 or 6.
Yeah, but
Not that the total's infinity, no.
no.
I'll give you an example. Yeah, you've ruined it now, Auntie. Alright, I'll give you an example in a moment. You need me to scroll down? Okay. Look, I have to go ahead here. It shouldn't take you that long to write this stuff down. So let's have a look at an example. I want to calculate 3 minus 3 over 2 plus 3 over 4. There's a couple of different ways to think about it, but the first thing you should always do, is take the 3 out in front here. Make it a 1 at the start. So if I take 3 out, what do I get left with at the start? 1. And then this one? Minus a half. Here? Plus 1 over 4. And then here? What do you think would be the next one? Minus 1 over 8. And it continues with no limit. Even though it goes on forever, the answer actually is not infinity. If you look at this, it's exactly the same as our problem 1 plus or squared plus or cubed. But what would the or be to match it up? Or would have to be minus 1 over 2. See, the easiest one is to look at this one. It's the easiest to match up. Got it? Now we have a formula. What's our formula for this infinite sum? It's 1 over 1 minus r. So although the sum is infinite in length, the answer is finite. Finite being the opposite of infinite. Okay? So although the sum is infinite in length, the final answer is finite. Let me check if this is recording. Yeah. What's wrong, Andy? Andy?
Something wrong.
What's wrong?
1 minus 1 over 2.
I'm sorry. Again, I don't have a calculator. I'm sorry.
That is 3 over 2.
Oh, sorry. You're right. I apologize. Thank you. It should be 4.
6 over.
Look, just type it in on the calculator and tell me what you get.
1 minus half times 3.
No talking. Just type them, please. Is it 4?
It's 2.
It's 2. All right. Thank you. 2. Sorry. It's a long, long day. Hurry, quick. Come on. It's just a question. No, there's not. All right. So next bit of theory, I suppose you could say. Okay. Now, next example. It doesn't use this formula. Let's have a look here. Tn equals 4 minus 3 over Tn minus 1. And I tell you T1 equals 2. Please hand me the calculator. Okay. Now, what do we do to get the next term? How do we get the next term here? What do? We put 2 in here. And when you do that, you should get 5 over 2. And then how do I get the next term? Put 5 over 2 in here, and you'll get 14 over 5. And then how do I get the next term? Put 14 over 5 in there, and you'll get 41 over 14. And so on. So the next one would be 122 over 41. Now, if you look at each one as a decimal, this is roughly 2, this is 2.5, what was 14 divided by 5? That is 2.8, that is 41 divided by 14 is 2.93, this one here, 2.98. So what type of sequence is this? Convergent, divergent, or periodic?
Divergent.
Convergent, because it is not going to infinity, it is moving towards a constant. And what do you suspect the number it is moving to be? 3. But we can't be certain. It could be 3.1. Could be 3.2, it could be 2.99, we don't know. So how can we find the exact answer? What did you say?
Keep going.
No. Well, do you have an infinite amount of time?
No.
No. You hesitated there. So because we do not have an infinite amount of time, we will look at another way to find it. So what you'll do is, as you get further and further, or I should say, bigger and bigger, so like T100, T101, do you think the difference between these terms will be big or small? The difference? Small. And then what about if you had term 1000 and term 1001? Smaller, yeah. So if you had the infinite term and the infinite term plus 1, it'd be 0 then, yeah. So what we do, we go back here and we send n to infinity. So this becomes, and let me call these both x, for example, because we said that they'll be about the same, right? So this becomes x equals 4 minus 3 over x. Because we suspect that when it gets very, very large, this number and this number will be really, really close. In fact, the same. And we'll call it x. And this is the limit. Anybody got any ideas on how I could solve this? I'll do it up here. Have we? This is the second time you've given me derivative as an answer, and we haven't done it yet. Any other ideas? How can we solve this? How can we find x? What should we do first? Yeah, well, the first thing we should do, Andy, times x. So we get x squared equals 4x minus 3, or x squared minus 4x plus 3 equals 0. So x equal 3 or minus 1. Which do you think is the actual answer? Because there can only be one limit.
3.
Yeah, because that's the one we suspect it could be. So we have confirmed that the exact answer, the exact limit is 3. This is quite a common question in the exam. Please write it down. I'll go down and then I can slide back up. Well, actually, this here you don't even need to do. No, actually, you do need to do. Yeah, so write all of this down. So start with that. Yeah, you see, the problem is, Amjad, if you just do this, you don't know which to choose. So we have to do this to know which to choose. Now please, listen. Those people who have a Casio 991 calculator, I can show you how to get all of these terms very quickly on your calculator, okay? So please take out your Casio 991 and listen carefully. There's nothing down here that, but that's all right, okay. But this here is more teacher ideas. So you don't really need that. So forget about that. And I know you're making my notes feel more important than they are. Right, write that down. It's precious, isn't it? Yeah. Have you got that? Right. As you're writing that down, those people who have it, take out the Casio calculator and let me show you what you do. So what you do is you look at 2a, and what is the first term? 2a, what is the first term? No, 2a, what is the first term? The starting term? 2. So type 2, press equals, press AC. What?
What AC?
2 equals AC.
Yes, firstly,
Okay.
the start.
You not explain.
No, this, oh, no, I'm not. Listen. Hey, listen. Look, I don't know if you're. Oh, no, never mind. Look, have you done that? So you press 2 equals an AC. So 2 equals AC. So that's the start. Okay? Then the next thing you do is look at the equation. It is 4 minus 3 over t, isn't it?
Yes.
So what you type in on your calculator, listen, is 4 minus 3 over answer key. So 4 minus 3 over ANS. Yes. No, I didn't say press equals, did I? I said type in 4 minus 3 over answer and then wait. Right? Right. Now, stop talking. Andy. Yes. Now, with Andy. That is not a Casio 991. That is some abomination to mankind, alright? Now, with that typed in, if you press equals, the answer on the screen is the second term, which is 5 over 2.
Yeah.
Press equals again, and that's the third term, 14 over 5. Now, keep pressing equals to get more and more terms. Go on, keep pressing.
Don't.
No, keep going. You can get there. No, keep going. Keep going. Yeah. Yep. Now, hey, Andy Ammer. In the exam, I'm giving you a shortcut here. In the exam, for this question, where they're asked for the limit, you are allowed to use your calculator to generate this list, because the real marks go for this, and then you only need that list to figure out which one to choose. Okay? So write that down, and then I'll look at an example from 3. Was this yours? Or?
That's mine.
Yeah. What's that, Amber?
Only get an equal 3.
Yeah, we'll get the tray.
Is it finished now?
What's wrong?
Yeah, I can buy that in Argos.
Okay. Example from number 3 now. What? Hurry up, hurry up. Okay, example from number 3. Example. Now, what was the name of the sequence in number 2? What type of sequence was it? Come on, vocabulary, let's go. What was it?
Convergent.
It was convergent and it was a recursive sequence. What? No, I was looking for convergent and recursive. Now, let's look at this one. So the first term is when I put n equals 1. So if you put n equals 1 into this, what do you get? Well, you'll get minus 5, the minus is on the outside of the fraction. You'd get 5 plus 8 plus 5 over minus 4 plus 2, whatever that is. Yes, absolutely. So just type this in, but put n as 1. What is it?
Minus 4.
Minus 4.
And the 5 in front and 5n square is minus 4.
No, I think it's okay.
Oh, yours.
The minus is in front of the whole thing.
And then the minus in front of 4.
Yes.
So it's minus.
So it's like that if you want. Sorry, so what do you get here? Minus 4?
Minus 9.
Actually, I think you might be right. Sorry, Andy. That's 18 over minus 2. Which is? 9. Yeah. Andy, you can't pretend like you were saying 9 all this time. Is it 9, yeah?
Yes.
Yeah, all right, fine. Now, look, I won't calculate each term, but well, we'll just do one more. So, oh no, I don't trust you. So, you keep getting more terms, and like before, it's moving towards a limit. It's convergent. But the question is, how can we calculate the limit here? So what you do for this one is you simplify it by dividing the top and below by the biggest power term. So what is the biggest term here? It's n squared. So you divide everything by n squared. Let's see what you get. So what's 5n squared divided by n squared? 5. And then 8n divided by n squared? 8 over n. And then 5 divided by n squared? 5 over n squared. And then here on the bottom? Minus 4 plus 2 over n. Now, what happens here is, when the n gets bigger and bigger and bigger, each of these terms, because they have n in the denominator, gets smaller and smaller and smaller. So when n goes to infinity, all those parts cancel, and you'll just be left with 5 over minus 4, with a minus in front, so that's 5 over 4. So let me just put a line here. So all of those cancel. So the trick is to divide everything by n squared. And then it becomes clear what part of the fraction disappears and what part of the fraction remains. Good, I'm seeing lots of satisfying head nods here. That's good, that's good. So I'll write this one down and then we'll do example 4 in a moment. Yes, yes. Oh no, we're not getting satisfaction up the front here. What's wrong?
How does the n squared can be?
The and how does that all that cancel out?
I divide everything by n squared. So you're happy with that part?
Yeah.
Each of these get divided by n squared. N is the term number, like first, second, third. So if you want the limit, you want n to shoot to infinity.
Uh-huh.
A finite number over an infinite number is 0. It vanishes away.
Okay.
Okay, so you just made it vanish.
I made it vanish, yes. I'm a mathematician, yes.
So what will be the number on the right, which is the constant?
What? These blue ones?
Yeah.
They all vanish, yeah.
All those constant, like.
Anything go on.
Yeah, look, to make it perfectly clear, if you have a number over something infinitely big, it's gone. It's 0. Yeah? Okay.
Vanishes.
Vanishes, yeah. That actually is the maths term for when you send something to 0, it vanishes. No. You see, if anything, you should be saying, teacher, can we stay longer because the weather is not so good outside.
Is it coming to
No, because I want to go home.
Don't be scared, you never see Muhammad.
All right. I'm going to do example 4 now. Do you have this taken down?
But what's the solution?
Here it is here.
This is D2.
No, this isn't T2, sorry. Right here. The limit is 5/4. This is called the limit. Now, how can you check if this is right? One way to check it is if you put a very large number in for n, what should the answer be? It should be roughly equal to the limit. So just take out your calculator, type that in, but put n as 1,000 and see what you get. The 1,000 term. Come on, type it in, don't just sit there.
But n is 1,000.
N is 1,000, yes, the 1,000 term. And I got 1.25206, etc., which is very close to 1.25, the correct answer. So for example, here if you calculate the 1,000 term, you would get 1.252 as an example.
So this could be a method of checking it, but
Yep,
it's,
sure is, yep.
but it's not an answer, not a way to get the answer. Because it's
No,
not exact.
no,
So
no,
it's just a check.
yep.
I got 1.24.
I have a feeling that you lost a 0 in one of your n's in your fraction. Do you have 1,000 in each term? Not 100 in any of them?
1.24862.
Give me the calculator. You typed it in wrong. The minus is in front of the whole fraction, not just 5. Well, yeah, that's what I said, 1.252.
What's the difference between 1.25 or 1.24?
The difference is 0.01. Obviously. All right, last example now.
So
What?
I guess this means 5/4.
Yes, 5/4 is 1.25, correct, very good. Okay, what? Right, last example now. I'll do like this one here, 0.7397. 7397. So what you notice here, this is a decimal that repeats itself. 7397, 7397, 7397, etc.
So it's 387.
Yeah, it's sure periodic. So we would like to write this as a fraction. How can we do that? Well, what we do is we recognize that this is equal to 0.7397 plus 0.00007397 plus 0.123456787397. This and dot dot dot. This looks a lot like our infinite sum from the start of the class. Except what number do you need here? You need 1. Yeah, remember we need 1 here. So what I'll do is divide everything by this. So that's equal to 0.7397. 1 plus, now can somebody type this in and then divide it by this? Because I'm taking this out of everything. What did you get?
Oh, then the other one is.
No, I want this divided by this because I'm taking this out of everything.
Just one color.
Just give me the calculator.
110,000.
1, 2, 3, 4, 7397 divided by 0.7397. So that's 1 over 1, 2, 3, 4. And then the next one, when you take it out, it'll be 1 over 1, 2, 3, 4, 5, 6, 7, 8, etc. So this equals this, and this equals this. Now, this here looks a lot like 1 plus r squared. And you see here, r equals 1 over 10,000. So this becomes 0.7397 times 1 over 1 minus 1 over 10,000, which equals 1. Now, I want everybody to take out their calculator, type this in, and write it as a decimal on your screen. And it should be equal to the original decimal up the top. So this is how you can change a repeating decimal from a repeating decimal into a fraction. You got it? So your homework is, which you can start now. Well, it's just, yeah. So your homework, which you're to start now, is the first 4 from each. Amjad, what's your homework? Yep. And when you talk to the people tomorrow, you'll have a lot of things to talk about with limits. Yep. You meet the head of the medical department and you say, wait till I tell you what I know about limits. Start these now, okay? The first 4 from each.